So in this experiment, we're trying to separate a mixture of 11 compounds using HPLC. And this is our data sheet, which we select here in the first step. The next is you would select your input column. So here I've highlighted these in blue, and these would be your inputs. And now your outputs are highlighted in green, which we'd set here. Now next you want to select a parameter sheet or create a new one. So here we are going to be creating a new one. And you'll see here it's generating a new parameter sheet for us. So here you'll have your inputs. And I'm going to be using the lower and upper bounds, which was taken from this paper. And this is quite important because, say, for example, you know that your column can only have an initial organic modifier concentration of between 5 and 60%. Otherwise, it might damage the column. You don't want the algorithm to explore options out of those bounds, so you can set those bounds accordingly. And then you have your decimal precision, which is set here as 2 for default, and your data type, and these are all continuous variables. But there's the option for if they were discrete or categorical. And your objective. So this R-res-crit value is just a measure of how well your peaks are separating from one another, so how well your compounds are separated. So you want to maximize that. And then the number of peaks you also want to maximize because you want to separate all the peaks possible. But that's a discrete variable. And then for the time the last peak elutes is essentially how long your experiment's going to be, how long that run will be. And you want to minimize that because that'll save you time and it'll save you money. So next on step 5, you can set the desired number of recommendations that you want. And here it's set to 3 by default. And this will just be the number of experiments that the algorithm will generate that you want to try next. Next, you want to determine the degree to which the algorithm will explore or exploit the bounds, 0 being exploit and 1 being explore. And here it's set at 0.5, so in the middle. So now you're ready and you can press calculate recommendations. So now the Matterhorn plugin has used active learning, so Bayesian optimization, to analyze our results from our previous experiments and suggest new experiments predicted to improve our results. And you can see here that a new sheet has been generated, and this will show our recommendations that the algorithm has given us for new experiments to try. So what you'll next do is you'll go into the laboratory and try out these new experimental conditions and record your outputs and then feed that back into the algorithm.